So in this video, we're going to take a look at the Cromemco ZPU Reproduction Kit that's in the white box down here. And so I thought we'd start by looking at an original board. This is an original board. It's a Rev-E. It has been stripped at the moment. Parts were tested in other places. The heatsink's been removed, but this was a fully operational Rev-E. A ZPU, like I say, that is the model that's been used to reproduce the kit from. At least it's one of the models. Like I say, it was a good running board. I've just pulled the chips out in the heatsink for some other work. We have next to it down here the reproduction board. I wish this board was stuffed, and it's not. We have the reproduction board here, fully built, fully tested. This board's been running for at least a week, if not a couple of weeks. The kit, everything on the board is included in the kit. The sockets, every last component is included in the kit. We'll look at how I've kitted that all up. It's, solder the board up, configure it, plug it in, and hopefully run. Or, there's no bodge wires or anything required. It is just a reproduction of the layout of the original board. There's been a couple little tweaks made for things like moving some capacitors to get a little more clearance from the heatsink. These are tantalum caps. The tantalum caps I'm providing, so these silver cans are the tantalum capacitors, the 510 microfarad that I'm supplying. They are correct to the original board. So you can see it's got the same style of capacitors. They are vintage. They have been tested on my bench, basically operating at their maximum voltage for a period of time just to make sure that, they're good caps, not going to melt down, explode, etc. The switch is the same switch as is on the original board. You can hear nice and how positive this switch is. Pick the board up, so it's just the board. Nice and crisp. This original switch is duller sounding. If I cleaned this original switch, it would be just as crisp as this switch is. So the switches, again, are new old stock. Each switch has been cleaned with a deoxit and a bunch of cycles to try to increase the reliability of the switch. The switches are working well. Of course, there's the 2 megahertz and the 4 megahertz position. 4 megahertz Z80A, power on jump dip switch. It's pretty straightforward. There's one change to the board that's captured in the silkscreen down here, cut to disable M-Write. So this board does produce the M-Write signal onto the S100 bus. The MSI CPA does the same thing. And you only want one board producing the M-Write signal, and so you can cut a little jumper link there. It's cut on this board so that M-Write from this board never makes it onto the backplane. And that way you're only using the M-Write generated by the CPA. Of course, the MSI CPA or the Cromemco CPA plug into the socket location right here, so you've got full front panel control. This has proven to be a very reliable board for me. It's been through a bunch of iterations. The first layout of the board worked. It's just been through a bunch of iterations that I've kind of tuned things for positioning, etc., getting to the point where I was happy with this. Modern manufacturing created some limitations on what I could do, like the C here for Cromemco can have no vias in the actual silkscreen, whereas on the original board, there are vias in the silkscreen, and that's just not allowed, and so those vias have been moved around, etc. But yeah, it's a pretty faithful reproduction of the original board, all the way down to the layout. The schematic of this board exactly matches the schematic of the original. So although this was drawn in KiCad, its schematic is identical to the original schematic. So the component designations all match the original exactly. So you can use the original schematic with the board, or you can use the ones that come out of my KiCad drawings. Either way, so what is actually in the box? Well, I know one side of this box opens up. It's this side over here. So there's no packaging in this box. Right now it's just the contents of what you're going to receive. Everything has a little packing slip in the bag. So this is the resistor bag. There's the discrete resistors. There's 3 of these SIP resistor networks, and there's 2 DIP resistor networks. But that's all the resistors that are required. There's information on here to kind of make it a little easier to deal with, like the color coding of the resistors. And I think even in the bag is a little color code sheet here that just shows the resistor color codes, make it easier to work through them. There's a capacitor bag here. It's got all the capacitors the system needs, including those 5 tantalums. So these are those tested tantalums. been able to match specifically values all the way down to the 0.005 microfarad. I thought for a while I'd need to substitute a 0.0047, but I found 0.005 microfarad disc caps. So again, it's the cap bag. All the capacitors are there. There is kind of a component bag here that has the 7805 regulators, the 8 megahertz crystal. There's a 2N3904 transistor, the dip switch, and the speed select switch. And again, this switch has been serviced. It's been cleaned as part of my packaging, so it should be a good switch. The issue that's keeping me from shipping these at the moment is I'm still waiting to get the final heat sinks out of China. We're having the heat sinks custom made in China because you can no longer buy this specific heat sink. But in the kit, you will get a heat sink. You'll get the mounting hardware, screws, nuts, and lock washers for it. So that's included. This heat sink was actually used for a long time on one of these boards here. And it's been pulled off just to have a heat sink in a bag. So I think that's what this heat sink is. Anyhow, you'll have a bag with heat sink and mounting hardware. You'll get a bag with all of the sockets that are required. So all the 16 pin, the 14 pin, and the 40. And so the board is completely socketed. You get the sockets. And finally, you get the logic. And this logic is consistent with the original schematic. So if it called for like a 74-164, you're getting a 164. You're not getting an LS-164 or an F or whatever. You're getting the correct logic family. There is LS logic on here as well. So there's some LS04s. You're getting LS04s. There's 174S, 133. You're getting a 74S, 133. So the TTL variants match exactly what the original schematic and board used. And it took a while to find all those parts and source them. But again, I want it to be as accurate a reproduction as I can. So really, that's the component stack up. There's a manual included. So there's a welcome page here with your board serial number on it, the packaging date, etc. on there. There's some things I talk about for assembly errata, the 10 microfarad tantalum caps. Some of the caps I have are house marked, others are marked 10 microfarad, so we cover that, and we talk a little bit about how to find the positive lead on the cap. The original manual says the SIP resistor packs have a little 1 printed on the SIP package, and that's not true. The ones I have a dot, and so we cover that here. The original manual talks about using a number 24 wire to secure the crystal in place, and I just say you can use one of the tantalum capacitor leads. It works just as well. And resistor capacitor leads can be used instead of this number 18 wire that's in the original BOM. So it's just kind of calling out some changes that you should be aware of before you assemble. There's a couple of quick notes here on using it with the MSI 8080 CPA panel, talking about MRite. We covered that. And how the speed indicator LED works. It replaces the stack LED on the CPA. And finally, the build of materials. This is all the components that are, of course, in the kit. Their designations on the board are here. Quantity, markings, etc. And then finally, we land at the manual. And we actually have the circuit board next. Let's pull the circuit board up out of here. You will, of course, receive a blank PCB. This is a production PCB. This is from the batch of first 5. It is a proper hard gold edge connector. It's not ENIG like some people are providing. ENIG is a softer gold. So this is a proper hard gold. It's appropriate having on an edge connector. And it's a nice silk screen photomask board. It's made in it's not a prototype board. It's actually made in a production board shop. That's intentional. I made a lot of prototypes, such as, that's actually a production board. I've got several prototype boards that less expensive to have manufactured, but I wanted a good quality production board, which is what's provided in the kit. It's just a nice board, hard gold, like I said. Hazel surface leveling for all the solder pads. It does come with a manual. We'll take a look at what's in the manual here, actually, just because there's a lot of content to cover, a lot of additional stuff in the manual that may or may not be useful to you. So, one of the supporters of this project, Ken, spent significant time cleaning up the manual. He's got a really nice copy of the manual, and he scanned it and did a lot of work to clean it up. I printed it on kind of a yellow-orange paper here. It will be on a more proper brown paper the card stock for the manual. This is just what I had on hand. And we get into the original manual, and it's the Cromemco ZPU Central Processing Manual. Of course, it gets into table of contents and takes you through basically all the technical documentation for it. So this is the original manual, and it completely applies to this version of the board. Completely applies because it's just the same layout of the board from back in the day, reproduced. It's a reproduction. So the original manual takes you through how the, theory of operation, all that kind of stuff. The manual that Ken worked from did not have the assembly instructions, and I've added that to this manual. I think they later only sold assembled boards, perhaps. But you'll find the assembly instructions here added to the manual. And again, the component designations are matched exactly. The original, there was a couple of typos in this that have been fixed. Things to make it, consistent and correct. Of course, there's a limited warranty from Cromemco. Good luck with that warranty. We get in then to stuff I've added. So there is a component placement diagram here that basically wants you to blown up image of the board and where all the parts go. And you'll notice, like for R5, it says 270. It's a 270 ohm, 10 microfarad. So all of the discrete components have, 0.005, etc. All the discrete components have the value in the silk screen and in the diagram here. This is the silk screen, in the image here on top of the copper. So the silk screen, you can assemble it directly from the silk screen. You can use the assembly manual. You can use this sheet or not. The board and the components are enough to successfully build it. There's the original Cromemco schematic. Ken put a lot of work into cleaning this up and making it very readable, and it is very readable, actually. Even printed at this size, it's very readable. Very happy with how this has turned out. So the original schematic on a single page looks great. As I captured this in KiCad, it's become a multi-page schematic. It's just how things worked. So there's the boards, the different sections of the schematic and how they're tied together. It's a pretty normal front page. Power supply section on the board, so all of the ICs and everything that receives power, the 7805s, etc. It's all here, and then there's some notes here on the pull-up resistor packs. There's 3 SIPs and 2 DIPs, and I've got notes here that make it much clearer what's connected to what. There was some amount of reverse engineering I had to put into to make this make sense and be consistent. And then you just jump into schematic sections, control logic. There it is. The Z80 core. So the Z80 on the system and how it interfaces out. So again, it's just normal KiCad style schematics. Power on jump, all this is here. And then finally, when I get a schematic kind of this complex, I like to put a guide in. It just gives you additional information. The unused gates, there's a bunch of notes here on various things, and there's an interconnect sheet here. So if you're looking in the schematic and there's an off-sheet connection called X08, you can come look up X08 here and say, control logic section, IC32 pin 13, it goes to the Z80 core sheet, IC424, IC4311, and IC4312. So those interconnects that jump off pages that don't really give you an indication of what they are, they're all mapped out here to make it easy to jump between pages. So I'm very happy with the schematic, how it's turned out. I will be, hopefully today, getting down to get the manuals printed. I printed this myself as a prototype manual. They will be printed at a local printer here, I believe, just because they can do a better job. And when they 3-hole punch, the punches will line up, mine don't. I may spiral bind these as well. I haven't decided. Don't really know, but really, there we are. What you will find in the kit is covered here. I expect to have the first 2 kits released for sale here in the next week or two. Today is what, the 23rd of September, 2025, I believe. We're in the middle to, well, we're 3/4 of the way through September 2025 when I'm shooting this video. I expect to have a couple of heat sinks here in the next week or two, and that'll release 2 of the kits, and there's more heat sinks coming. I may have led with this. Tariffs and other stuff have made it difficult dealing right now with the heat sinks. You know, all I'm missing are the heat sinks. Everything else is really ready to rock and roll except for the manual, and there's not a long lead time on getting manuals published well. Got 2 different print shops in town here that can do manuals for me. So, kind of put this all back in the box. I have an idea what the suggested, well, what the retail is going to be on this. I'm not going to make a ton of money on these. It's just really hard to make money on these kind of kits when I've had to source parts from all over the world. I will say that I have enough parts to have about 12 or 13 kits for sale. Depending on how they sell, that may be it. There may never be another run of these. This complete, it's hard to say. It really depends. If I can sell this out in a reasonable amount of time and there's still interest, I may do another run. It's not cheap bringing all these components together. Like all of the Retrotech Reboot kits are, the entire package, design package, will be released on the web at some point, such that somebody could order, you know, custom-made heat sinks, printed circuit boards, all the mechanical design files, schematics, PCB layouts, all that stuff will be released and made public domain. That's one of the things that I'm very committed to here. Is I have expenses up front to bring these together, and once I get myself to a break even, I can consider then releasing that stuff. So there it is. I look forward to your feedback. What have I got stuck on the box? Oh, it's actually something stuck in it, peeled paper. Sales will probably be North America only, at least for the first couple. We'll see. I've got an email list. That'll notification of the first availability of the kits will go out on an email list first. shadowtronblog@gmail.com, SHADOWTRONBLOG, shadowtronblog@gmail.com if you want it to be added. Certainly send me an email. There it is. I guess that covers everything I wanted to say in this video. And I'm looking forward to somebody out there actually buying the kits and building them. Hope you have as much fun with them as I'm having. We'll talk soon.